All right, boys and girls, let's hop into lesson 46. Today we are going to practice mentally multiplying decimal numbers both by 10 and by 100. As is often the case in math, there is a simple rule of thumb to follow. But before we get to the rule of thumb, let's try to understand exactly what's happening with our numbers. Our book begins with this sentence: when we multiply whole numbers by 10 or 100, we may mentally attach zeros to the number we are multiplying to find the product. And in fact, you know that 24 groups of 10 equals 240. We simply take the number we are multiplying by 10, rewrite it, and add the 1 0 from the 10. In the case of 24 times 100, we will add 2 zeros and we get a product of 2400. While it may seem like we are just attaching zeros, we are actually shifting digits to the left. When we multiply 24 by 10, the digits shift one place to the left. When we multiply 24 by 100, the digits shift 2 places to the left. The zeros hold the 2 and the 4 in their proper places. This might be a little bit easier to visualize if we look at it in chart form. Here we have 4 columns, our thousands spot, hundreds, tens, and ones. We begin simply with the number 24, 2 tens, 4 ones. When we multiply 24 by 10, we are shifting the 2 one place to the left and the 4 one place to the left. The 2 now sits in the hundreds spot, the 4 in the tens, and the 0 takes up the 1 spot. Similarly, if we multiply 24 by 100, we shift our digit one more place to the left, or if we were starting with 24, it actually goes 2 places to the left. The 2 now moves to the thousands, 2 places, and the 4 has moved 2 places and sits in the hundreds, and our zeros are used as placeholders in the tens and the ones spot. Now let's shift our focus to looking at decimal numbers. When we multiply decimal numbers by 10, the digits shift one place to the left, same as when we were multiplying whole numbers. When we multiply by 100, the digits shift 2 places to the left. Let's look at a very similar chart, only this time we're going to start with a decimal number. In our chart now, we have a tens column, a ones, our little decimal column, our tenths, and our hundredths spot. This time, instead of starting with 24, we'll start with a 0.24, and you can see it written out with the 2 in the tenths spot and the 4 in the hundredths spot. Now when we multiply it by 10, our digits will shift one place to the left, and in fact, the 2 has moved from the tenths spot to the ones spot. The 4 has moved from the hundredths spot to the tenths spot. And in the case of 0.24 times 100, our digits will shift 2 places to the left. The 2 jumps from the tenths spot over 2 places to the tens place value. And the 4 jumps 2 places over the tenths, now to the ones spot. And we know that 0.24 times 100 truly is 24. Now here's the rule of thumb. Although it is the digits that are shifting 1 or 2 places to the left, we get the same effect by shifting the decimal point 1 or 2 places to the right. Therefore, anytime we multiply a decimal number times 10, simply shift the decimal one place to the right. When we multiply a decimal number by 100, shift that decimal place 2 spots to the right. Here we go. 0.24 times 100, we'll shift it 2 places. Here is our new decimal, and our answer is 24. Let's look at a few examples. In the case of example 1, we're asked to multiply 3.75 times 10. Well, looking at our rule of thumb, we're going to move that decimal 1 place to the right, while we are understanding that it's not so much hocus pocus moving decimals around willy-nilly, but in fact, whenever we multiply by 10, our digits themselves are shifting to the left. Well, 3.75, move it 1 place to the right, and our new product should be 37.5. Woohoo! We did it. And in the case of 3.75 times 100, we'll do a 2-place shift. 3.75, we'll move it 1, 2, and our product is now 375. Exactly as our book has told us. Now let's look at a little bit more involved problem. Just remember everything we've learned, work through your problem carefully, and it's not difficult. In this case, we have 1.2 over 0.4. We're multiplying it by 10/10, in other words, another name for 1, and we are going to rename this fraction or division problem, they're both one and the same, into a form that doesn't involve decimals. Again, this is actually setting us up for a future math lesson. Well, let's simply multiply our numerators. 1.2 times 10. I'll shift that decimal 1 place to the right, and now we have 12. And again, we have 0.4 in our divisor, or our denominator. We'll move it 1 place to the right, and now we have 4. And in fact, if we were going to simplify it or divide it out, we would come up with a quotient of 3. What this problem is preparing us for, boys and girls, is that as we get into division problems where we have a decimal in the divisor, we're going to quickly learn we really can't do those problems, and we have to come up with a creative way of getting rid of the decimal as it appears in divisors. And when we do a quick peek down here, you'll see that we did, in fact, solve this problem exactly correct. Would you please mark the following lesson practice problems and complete them? Would you please do A, E, F, G, H, and I? Once again, that's A, E, F, G, H, and I.